Okay, now we have the two vectors that despite the force distribution or the force direction, which is actually my tension from CD, given here, and we got the distance. Now at this point I just realized I got a little problem. The distance in C is going to be given by this one right here. This one right here. However, that 0.8 is not correct. That 0.8 should be 0.08, since 80 millimeters is 8 centimeters, which is 0.8. So having clarified that, I just must say that it doesn't affect the rest of the calculation that we did for the force. Those were actually correct. This was the only mistake we got, well, I got. And we can continue. So applying the equation for moment, I know moment about O vector will have one component that goes into the I direction plus another component that goes into the J direction plus another component that goes into the K direction. So for the component that goes into the I direction, we are going to use the distance in Y, the force in C, minus the distance in C, force in Y. This will deliver that I will have 0 times minus 128 minus 0.08 times 96. Now from here we can see that this component will become 0 because we are multiplying by a 0, so it goes away. Then for the components in Y, we will use distance in C, force in X, minus distance in X, force in C. This will deliver that we have 0.08 times minus 120 minus 0.3 times minus 128. Here we don't have any component that actually goes to 0, so we have to calculate this. Now the last one, the component of the moment in K. We're going to use distance in X, force in Y, corresponding to the colors, distance in X, force in Y, minus distance in Y, force in X. In here, we will have 0.3 times 96 minus 0 times minus 120. We got another component that multiplying 0, so it goes away. Now in this, we can just go and calculate what are going to be the results. This like this. Sorry, I'm just trying to make it a little bit more appealing or smaller so I can work with this part. Plus, plus. So the result for the moment about O component is going to be given by minus 0.08 times 96, which is minus 7.68 in I. Then I will have 0.08 times minus 120 minus 0.3 times minus 128. It's going to deliver a positive 28.8 in J. Finally, we'll have the 0.3 times the 96, giving us again 28.8 in K. So supposedly this is going to be the moment in the three different axes. Now, how can we actually see if this makes sense? Let's erase this port, and this port, and this port. I know this vector, the vector that goes from A to C, can be decomposed into a different set of distances. We got a C distance, we got a C distance, we got an X distance that's actually 0, and we got one X distance here. Now, the force that goes from C to D can be actually decomposed too into a component of the force that goes up. Here's going to be our force in Y. A component of the force that goes back, that's going to be our force in C, and a component of the force that goes back to in X, force in X. Now, the combination of these forces with these distances will give us the moments. Let's see. The force X, it's only going to be perpendicular to the vector of distance, or the distance C. That means we will have C times X, and it's going to create a moment like this in the Y. Now, what else is creating a moment in the Y? Well, the combination of force C and distance X. That means this force of minus 128 times this distance of 0.3 meters is going to create a moment that goes like this. At the end, these two are going to be bigger than the last one, so they're going counterclock, creating a positive result. Makes sense. Finally, for the C-axis, that C-axis only be composed by this force in Y, which is 96, and the distance in X, which is 0.3. That makes sense. We have a force of in Y of 96 divided into 3. It's going to be like 28.8, something close to that. It should be 28.8 times divided by 1.3, 96. Okay, we're right in that part. So, makes sense. What about the X? Well, for the X, the one that makes that rotation is going to be the force in Y times the distance C, which is actually given in here. Force in Y, distance C. And we will have 0.08 times 96 negative. That means it's actually moving like that. Makes sense. So the results actually made sense. That's the total moment about point A created by this force.